Last class we discussed about the irrational numbers. So how to prove that irrational number as a irrational number. So we discussed about in the last class. This class we discussed about the prime numbers. So in the composite number, how to express the composite number in the product of prime numbers, and also we discuss about the LCM and HCF of the numbers. So first we discuss about the prime numbers and composite number. So what is prime number? So what is prime number? So we already know that. So real number is a combination of rational and irrational. So now we get to what is prime number. So the prime number is the number divisible by 1 and itself. So the number divisible by 1 and itself is called prime number. For example, so we can take 2. 2 is a prime number. So why we call 2 is a prime number? So 2 is divisible by 2 and 2 is divisible by 1. So no other number, so not divide the 2. So that's why, so 2 is called prime number. 2 is called prime number. Okay, so like that we take another one example, 3. So 3 is also prime number. So why we call 3 is a prime number? Because so 3 can divide by 3 and 3 can divide by 1. No other number divide the 3. Okay, no other number divide the 3. So that's why 3 is called prime number. So 3 is also prime number. And how many prime numbers we have? So infinitely many prime numbers have in the number system. So 2, 3, 5, 7, 11, 13, so on. So like this we have infinite number of prime numbers are there. Okay, are you understand what is prime number? So prime number is the number divisible by 1 and itself. The number divisible by 1 and itself is called prime number. You can look at here. So 2 is prime number. So 2 is divisible by 1 and 2 is divisible by 2 only. Only from these two numbers 2 is divisible. No other number divide the 2. Okay, therefore 2 is called prime number, like that. So 3 is divisible by 1 and 3 only. Okay, no other number divide the 3. Therefore 3 is also called prime number. So here you can look at this number. So 5 also has the factors of 2, 5 and 1 only. Okay, so in other words we can say that prime numbers have only 2 factors. How many factors? Prime numbers have only 2 factors. The 2 factors are 1 and itself. So therefore these numbers are called prime numbers. Like that we have composite number. So what is composite number? Composite number. So composite number means, so the number with the other than prime numbers are called composite number. Other than prime numbers are called composite number. In other words, so the numbers which have more than 2 factors, the number which have more than 2 factors is called prime composite number. So for example 4. Okay, so 4 is a composite number. Why we call 4 is a composite number? So 4 can divide by 4 and 4 can divide by 1 and 4 can also divide by 2. Okay, so here, so other than 1 and 4, so 4 is also divisible by 2. So therefore we can say that 4 is a composite number. 4 is a composite number. Okay, so when you divide the number by other number, you get the whole number bandre, then it is called composite number. So we can take another example. So 22 is a composite number. So why we call 22 is a composite number? So because so 22 can divide by 22. So what we get 1 by. Okay, so 22 divide by 2, so we get 11. Okay, so 22 divided by 1 we get 22. So like that, so we get the number more than 2 factors irodrinda, so 22 is called composite number. Okay, so now you can understand what is prime number, what is composite number. Okay, so in the number system only the numbers na we divide prime numbers and also composite number. So the number which have only the number have only two factors, otherwise the number divisible by 1 and itself is called prime number, and composite number means the number which have more than two factors, otherwise more than two factors is there, then it is called composite number. Okay, so now we go to our main topic. So express the composite number as a product of prime numbers, product of prime numbers. Okay, so we take one example. So express 90 as a product of prime factors, product of prime factors. Okay, so this one we have to divide. Okay, so only by prime numbers. So 90 we can divide by only the prime numbers. So we know that 2 is a prime number, so 90 is a even number, we can divide by 2. Okay, so 2 4 is 80, 1 carry होता है, 5 is so 2 5 is. Okay, so 245 is we get 90, like that. So the number is end with 5, therefore we can divide by 5. Okay, because 5 is a prime number. So 5 9s are 45, like that. So we can 9 we can divide by 3, so 3 is a prime number. So 3 3s are 9, so 3 1s are. So 90 we can express as product of prime numbers, that is so 2 into 3 into 3 into 5. So this one, right, 2 into 3 square into 5. So this is the expression for 90 as a product of prime numbers. So like this we can express the several numbers, every composite number in the form of prime factorizations. So this statement is called the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? Every composite number can be expressed as product of prime numbers. It's called fundamental theorem of arithmetic. Okay, so like that we can take the second example. Okay, example 2. So we take 72. So 72 is a composite number. So this number also we can express in the product of prime numbers. Okay, so 72 is a even number. So this is divisible by 2. 2 3 is a 6, 1 carry. So 12, 2 6 is a 12. Then it is also even number, so you can divide by 2. So 2 1s are 2 8s are. Again you can divide by 2. 2 9s are. So 9 cannot divide by 2, so therefore we can take 3. So 3 3s are, then 3 1s are. So therefore we can express 72x 2 into 2 into 2 into 3 into 3. Okay, so this is, so 72 we can express 2 to the power of 3. Okay, so we are applying the exponents law. So 1 1 power is there, so basis same is there, so we add 1 plus 1 plus 1, we get 3. So like that here 3 to the power of 2. So the prime factor of 72 is equal to 2 to the power of 3 into 3 to the power of 2, like that. So every composite number we can express in the product of prime numbers. So like that we can take the larger number also. So now we take the larger number. So to the larger composite number, so this 1008 is the composite number. So this one we have to express here is the product of prime numbers. How to express this? Okay, so same, follow the rules. So 2 is divisible by 108 is divisible by 2. So therefore it is 5 is 10. So 10 is there, so 0. So 4 2 is 8. 4 2 is 8. So like that. So it is also divisible by 2. So 2 2 is 4. 1 carry. So 5 is so n is 2 2 is 4. They again it is divisible by 2. 2 1 is 2. 2 is 4. 1 carry. 12 is there. So 2 6 is 12. Again it is divisible by 2. 2 6 is 12. 2 3 is 6. Okay, so 63, so it is not divisible by 2 because it is a odd number. So therefore we can take 3. 3 2s are 6, 3 1s are. Again go with 3 7s are, so then 7 1s are. So therefore, so 1008, 1008 we can express 2 into 2 into 2 into 2, 4 times 2 is there, and 2 times 3 into 3 into 7. Okay, so this one we can express 2 to the power of 4 into 3 to the power of 2 into 7. Like that we can express 1008 in the product of prime factors. Product of prime factors. Like that we can express. Like that we take another one number. So 240. 240. So this one, how to express this one? So this is a even number. So this is also divisible by 2. This is also divisible by 2. So 2 1s are 2 and 2 2s are 4. So 0 you can reduce. So 120 into 2 we get 240, like that. So 120 also we divisible by 2. So 2 6 are, so 0 we can reduce. Okay. So then divisible by 2, so it is 3s are 30, 2s are 60, then it is also divisible by 2. So 2 15, 15 2s are 30, so then 15 we cannot divisible by 2, so therefore we can take 3. So 3 5s are, then 5 1s are, so therefore, so 240 we can express, so 2 into 2 into 2 into 2 into 3 into 5. So therefore you can express 2 to the power of 4. Okay, because 2 is 4 times is there. So then 3 into 5. So like that. So 240 we can express in the form of prime factors. So next we have another concept, HCF and LCM of numbers. HCF and LCM of numbers. So what is HCF? So in our lower classes also we studied HCF and LCM. Okay. So what is HCF? HCF means highest common factor. Highest common factor. Full form of HCF is highest common factor, and full form of LCM is lowest common multiple. Okay. So what is HCF? HCF full form is highest common factor, and LCM is lowest common multiple. It's called HCF and LCM. So how to find out the HCF and LCM of these two numbers? Okay. So we take one example and we find out the HCF and LCM of the numbers. For example, we take 81 and 108. So we take two numbers, 81 and 108. Okay, so these two are composite numbers. So these numbers we express in the product of prime numbers. Then only we can easily find out the HCF and LCM. So first find the prime factor of 81. Okay, 81 we know that it is divisible by 3. So 27 3s are 81. Then so 3 9s are 27. 3 3s are 9 and 3 1s are 3. So therefore 81 we can express 3 to the power of 4. 3 into 3 into 3 into 3. So like that. So 108. So it is also divisible by 3. So 3 3s are 9, 1 carry. So 8 are the 3 6 are. Okay. So then 3 1s are 2s are 3 4s are. So then you can write 2 2s are 2 1s are. Okay. Therefore this one 108 we can express in the form of 3 into 3 into 3 into 2 into 2. So here we have to find out the HCF of 81 and 108. 81 and 108. Okay. So what is the HCF is highest common factor. Highest common factor. That means so the number common for both the prime factor. ಎರಡು prime factor ಅಲ್ಲಿ ಕಾಮನ್ ಇರುವಂತ ನಂಬರ್ಸ್ ನ ನಾವು ಬರಿಬೇಕು. Okay. So which are the numbers here common? Here 3 is common. Here one more 3 is common and one more 3 is common. Okay. So here 3 is there, here 2 is there. So ಇಲ್ಲಿ in 108 prime factor ಅಲ್ಲಿ 2 ಇದೆ and 181 prime factor ಅಲ್ಲಿ 2 ಇಲ್ಲ. So therefore these two are not common number. So therefore so the highest common factor is 3, that is 3 into 3 into 3. So therefore it is 27. When you multiply 3 into 3 into 3, 27. So therefore HCF of 81 and 108 is equal to 27. Okay. So the 3 number is 3 times common is there. So therefore so 3 to the power of 27 is the 3 to the power of 3 is the highest common factor or HCF of 81 and 108. So like that we need to find out the LCM. So LCM you have to take the highest common least common multiple and here you have to take the highest powers. So 3 ಎಷ್ಟು time ಇದೆ ಅಷ್ಟು time ಬರಬೇಕು and 2 is also right that much. So here 3 to the power of 4 into 2 to the power of 2 ಆಗುತ್ತೆ. 3 to the power of 4 into 3 to work. Okay, so that means 3 to the power of 4 and that is 81 into 4. So we get so for 1 so 324. So LCM of 81 and 108 is equal to 324. That is least common multiple. That means so 324 is the smallest number divisible by 81 and 108. So no other smaller number divisible by 81 and 108. Okay. So this is called LCM of these two number. Okay. So LCM of these two numbers andre so the number divisible by both the numbers. So no other smaller number divisible by that number. So that is called LCM of the two numbers. Okay. Next we continue. We take another one example. 55 and 125. 55 and 125. So write the prime factor of 55. So 55 is divisible by 5. So therefore 5 ones are 1s. So therefore we can write so 55 is equal to 5 into 11. So 11 is also prime number, 5 is also prime number. So therefore we can write like this, like that. So 125. So we can divide by 5. So 5 2s are, so 2 carries, so 25 5s are. So then 5 5s are, then 5 1s are. So 125 we can write so 5 into 5. Okay. So in these two prime factors, so the common number is 5. Therefore HCF of 55 125 is equal to 5. HCF of 55 and 125 is equal to 5, like that. So LCM of these two numbers, so 55 and 125. So we have to take the highest power. So 5 we have two numbers, so 5 and 11. 5 and 11. So this one we have to 5 cube and here 5 to the power of 1 into 11. So in this 5 both side you have a common number, but adre so highest power is 3. So therefore we can take 5 to the power of 3. So 5 to the power of 3 means 125 into 11. So when you multiply these two, what do we get? So 125 into 125. So 5 7 3 1. So therefore 1375 is the LCM of 55 and 125. So like this, so we can find out the HCF and LCM of any two numbers. Okay. Next class we discuss about the other concepts. Thank you.